All right, if I want to derive this, you should see it's a quotient. So to derive it, we're trying to find y prime. For the quotient rule, the bottom, you're just going to square. So you can take x squared, that's the bottom. For the top, you derive the top, and the derivative of secant is secant x tangent x. You leave the bottom, then there's a minus, then you leave the top, and derive the bottom. The derivative of x is 1. So again, you derive the top, leave the bottom, leave the top, derive the bottom, and square the bottom. This is called the quotient rule. And then you just got to simplify this down. So in this particular problem, there are some possibilities. For instance, these can't be grouped together, neither can this, but you can pull a secant x out. That's one more way of simplifying this. So what I'm going to do is I'm going to pull a secant x out, leaving you x tangent x. I want to put the x in front of the tangent so it doesn't look like there are two x's inside of the tangent. Minus 1 over x squared. Now, could I also take the secant and put cosine on the bottom? Yeah, you can make the secant be a cosine on the bottom. You have to be able to manipulate and change it into different ways. So this is probably a decent one, but you also could possibly have a cosine x on the bottom instead. So that's that one. Now for this one, if I want the equation of the tangent line, what you need is you have x and y already. So all you need is the slope at 0. To do the slope at 0, you find the derivative of this. Now to find the derivative of this, there's two ways. I'm going to first do product rule, and I'm going to show you the other way. If I did product rule, the derivative of the first piece is 1. Leave the second. Plus, leave the first, and the derivative of x squared minus 2 is 2x. So the derivative equals x squared minus 2, and if we distribute this, you get 2x squared plus 2x, which we now have, looks like we have 3x squared plus 2x minus 2. That's the derivative. Now how do we find out the slope at 0? Because we want the equation of the tangent line. You simply plug 0 right here. So f prime 0 looks like it's going to be 3 times 0 squared plus 2 times 0 minus 2. So it's negative 2. So my slope is negative 2. Now, the equation of the tangent line, did I mess up somewhere?
Yes.
Where? This should be a minus 1? That should be minus 1? So that should be a minus 1. Good. So if that's a minus 1, that's a minus 1, that would change this to a negative 2x, correct? Is that right? Which would change this to a negative. Now if that's a negative, does that change anything to what we're doing in this particular problem? It does not change any of it, but those are minuses. Thank you for correcting me. We're still okay, but I didn't make a mistake along the way. Now the equation of the tangent line would be y minus y, so y minus 2 equals the slope, which is negative 2, times x minus 0. Which you could actually leave it that way, possibly. Or you could rewrite this one. It could also end up being negative 2x plus 2, because you can minus the 2 over and distribute the negative 2. So either of these are possible. Now, there is one more thing. That's the equation of the tangent line. How could we have done this another way? Basically, if you rewrite this, if I would have FOILed this to begin with, you would have had x squared minus 2x minus x squared plus 2. Now, This would be x cubed up here. X times x squared is x cubed, so never mind. That's it right there. And if you just derived each piece one by one, that'll give you 3x squared. This will give you negative 2. This will give you negative 2x. That'll give you 0. Does this match this? Yeah. It's all a preference. Do you want to do product rule, or do you want to just distribute and then derive it as a polynomial? It's your call.